బయటికి వెళ్ళినాక చూసి
Yeah, welcome everyone. Today I am going to discuss about the introduction related to the advanced engineering physics. That shortcut name is AEP. In this course, we have 5 units. Not like in your intermediate portion, here first unit and the second, third and fourth and fifth is completely different zones. The first unit belongs to the title, the crystallography and material characterization. This unit completely describe about the materials properties, whether it is a crystalline or amorphous, and how we can prepare it, the preparation methods, and the advantage of nanomaterials, what is the speciality of the nano, etc. In addition, this chapter is also discussing about the how we can characterize it. In intermediate, we know about the differences between the crystalline and amorphous, like the regular arrangement of atoms or irregular arrangement of atoms. For example, iron is a crystalline and rubber is like a amorphous. This kind of information you have you learnt in your intermediate portion, but here it is a little bit extra zone. That is, first we need to understand what is the properties related to the crystalline, what are the different planes oriented, how we can analyze that material. For example, I have given some material, you have to test it, and reverse engineering, you need to check what kind of material it is. There is such possibility by taking the X-ray diffraction pattern for the crystalline materials. That is one of the important tool, like a fingerprint. Person to person, like a fingerprint, how it differentiate. Similarly, XRD pattern of the crystalline material A and B is not same. By using the standard patterns of the crystalline material, there is a possibility to differentiate the materials one with respect to the other. Even we can check what kind of doping elements are present within the material. Similarly, we can check the morphological information by using the scanning electron microscopy, like a capturing the image by using the electrons as a source. So here the chapter 1 is completely describing about the what is the meaning of crystalline, how we can fabricate it, what is the properties, how we can characterize it. So this chapter is related to this kind of information. Coming to the second unit, that is the quantum mechanics. It's not a new word, already there in your intermediate portion, that name it as modern physics. In that we just discussed about the photoelectric effect, Compton effect, de Broglie hypothesis, Heisenberg uncertainty principle. These are the basic things related to the quantum mechanics, that is the science which deals about the microscopic objects like electrons, protons and the neutrons. See here, if you are talking about a person like a human or the car or the vehicle or the bench, these are related to the classical object, you are able to see it. Bigger objects, if you want to explain this kind of behavior, we use the classical mechanics. That standard form is like a Newton laws. Similarly, if you want to explain the quantum microparticles like electrons, the protons and neutrons or the subatomic particles, we need a different science, because the classical rules like a Newton laws are not valid. That kind of information is discussed in the chapter 2. It starts with the introduction to the quantum mechanics, de Broglie, Heisenberg uncertainty principle, the postulates, like what is the advantage of the quantum mechanics over to the classical physics, Schrodinger equation, particle in one-dimensional box, energy levels. All these parameters are discussed in the quantum mechanics. So it's like a different zone. Compared to the first unit, it is completely different. The third one is the quantum computing. It is one of the like a buzzing word in the present scenario. Everywhere we used to hear the quantum computing. Recently in Telugu states, the quantum valley is established in Amravati. Thousands of crores are investing in that. But what it mean? That is completely a different kind of like a computational process, which is not at all equal to the traditional classical computers, because the classical computer use the data like bits, like a 0 and 1, it sort out the data, the computation process take like a sequence manner, one after another. But in case of the quantum computing, all the data take it as like a single entity, and based on the probabilities, it will decide what is the result. So the basic difference between the classical computing and the quantum computing is, classical computing, due to the sequential manner, one after another, it takes huge time, whereas in case called classical computing, quantum computing point of view, lakhs of information, lakhs of pages data also, it takes as the superposition entity, and it checks the different probability functions. Finally, it will give as end result. It's not like a end sequential manner, one after another. So that is the added advantage of the quantum by computing. That's what the people are looking for, the advancement in quantum computing possibilities. But the drawbacks are there in the quantum computing also. But naming, saving the data, file name, for that purpose the quantum computing is not at all feasible. It is completely different zone, like a medical point of view, cryptography point of view, entanglement point of view, simulation point of view. We use the quantum computing. So once the quantum computing is established, our thought process is completely different, especially for the material or the very microscopic particles point of view. So here the quantum computing use the basic principles of the quantum mechanics. That's what the chapter 3 is related to the quantum computing. It is linked to the second chapter, but it is completely different part. And fourth one, magnetic materials and the dielectric materials, like magnetic properties and the dielectric properties. As we know that some material properties or the material nature that decide what kind of material it is. If the material is respond with respect to the magnetic, whether it is attraction, the repulsion, whatever it is, if it is able to respond it, that is called as magnetic. For example, here it is, take it as like a mouse. If I place it in the magnetic field, there is no response, whether it is attraction, repulsion, it's like a ideal thing. That's what it is, not a magnetic material. Similarly, we have the classification, in what way we can show some is magnetic, some is non-magnetic, what is the like a origin to create the magnetic moment in a particular material. That part we are going to discuss. And in addition, classification, dia, para, ferro, antiferro, ferrimagnetic materials also we are going to discuss. In addition, we are also going to discuss about the thing like what is the origin for the ferromagnetic hysteresis, in what way we propose the domain model to explain the ferromagnetic hysteresis. This part we are going to cover in magnetic properties. Similarly, dielectric point of view, what is the meaning of dielectric first? You should understand it is similar to the insulator. All the charge carriers are bounded, but it creates the polarization when it is placed in the electric field. That means the material which able to respond with respect to the electric field, that is called as dielectric. If it is not in the electric field, then it's similar to the insulator. So the material which respond in terms of electric field, that is the process of separating the positive and negative charge carriers, is called as polarization. That means that we are creating the dipole. So based on this, in what way we are creating, or in which material we are creating the separation of positive negative, that creates the different types of polarization: electronic polarization, ionic, orientational polarization, space charge polarization, etc. Similarly, so when you are going to the hospital, they may check the temperature, right? In recent, like a corona time, used to check the body temperature by using like a one instrument like called as pyrometer. That is also one kind of dielectric material. And some cases, the point of example point of view, some kids like wearing like a shoes, when they are walking on the floors, we used to get the lights. So how it is possible? That is related to the piezoelectric material. That means when you apply pressure on that, it able to generate the electricity. That is the part related to the dielectric part. So in case of dielectric, we used to discuss about the introduction, the difference between the dielectric and insulator, and what kind of dielectric materials are there. That part we are going to discuss in the fourth chapter, like dielectric and magnetic properties. Next and the last one is fifth unit, that is lasers and optical fibers. So laser, when you listen a word like laser, it's like a playing toy, but not at all. So it can be used as a toy, and it can be used for the military weapon. We can use it as like a military object to crash the enemy's aeroplanes. That much power is there. It is used for the play, and it is used for the cutting of metals, drilling, or for every purpose. The lasers are useful based on the power, what kind of power it is generating. So the same material, the same principle what we are using for the toys or the laser pointer is not same for the other kind of laser. That part we are going to discuss. What is the first? I start with the word like LASER. What it mean? Light amplifying, like increasing the intensity by using the stimulated emission process and radiation. Obviously we need to discuss about the simulation, like a stimulated emission process, how the light is amplifying, how the photon number is increasing. So what are the properties for the laser when you compare with the ordinary light? When you take in the ordinary light, it doesn't have the monochromaticity, directionality, intensity is less. But when you come to the laser point of view, it can guide the waves up to thousands of kilometers in a single stretch, and the intensity is very high. It must be some cases is equal to the sunlight intensity. And it is used for the industrial purpose. These are the general theory related to the laser point of view, and we also discuss about the applications related to the lasers, like a laser barcodes or etc. Optical fibers. Recent in Telugu states we use the word like data centers are establishing in the Vizag, and submarine cables are going for the one country to the another country for the internet purpose. We can send the secure data from one country to the another country by using these cables. But how these kind of cables are operate, how we can able to send the data from one place to the another place. For example, I am sending my voice from this place to that particular place. It is restricted in this particular room. There is no possibility to go out because the signal is diminishing its intensity. After certain distance, that signal may lose. But in case of optical fiber point of view, we are sending whatever the data, whether it is a video or the audio or any kind of data, is in the form of light. By using the total internal reflection principle of particular cable, it may move from one place to the another place like a thousands of kilometers without any kind of loss. So that principles we are going to discuss what kind of conditions we need to follow while launching the signal through the optical fiber, what kind of data we can send, and what are the possibilities of getting losses, and how we can overcome it, and what are the real-time applications for the optical fibers. That we are going to discuss in the 5th unit. So in overall, so by studying the advanced engineering physics, obviously the students able to get different kind of knowledges in different aspects. It is suitable for the CSC, it is suitable for the electronics and communication, and it is suitable for the EEE people. And finally, advanced engineering physics is one of the learning tool to improve your career point of view. Thank you.
చాలా ఎమోషనల్ అది